Hi folks, we're going to take a look at number 23 from page 273. So question tells us that we have a 20 centimeter pipe cleaner and that it's bent into a rectangle. And it specifically says use a quadratic model to find the dimensions giving maximum area. Okay, so you can't just give the answer, you actually have to use the quadratic model to show the answer. Now, first of all, I noticed the word maximum in there, so I should be thinking that I will be finding the vertex of a quadratic function in order to solve this problem. Okay, so here what we have is we have 20 centimeter pipe cleaner and it's being bent into the shape of a rectangle. Okay, so that means that the perimeter is equal to 20 centimeters. So if I label my rectangle length and width, that means that 2 times the width plus 2 times the length is equal to 20. So that's the information I have, but what they're asking me to determine is the dimensions that are going to give me the maximum area. So it's the area function that I actually need to work with. And of course, the area of a rectangle is length times width. The problem with this function is that it's a function of two variables, and I only know how to work with functions of one variable. So this is where we're going to use the extra piece of information that they gave me, which was that the perimeter needed to be 20 centimeters. Okay, so essentially what we have is we have two equations and two unknowns. Okay, and we're going to use substitution to get a function that has only one variable in it. Okay, so what I'm going to do is I can, here it doesn't make a difference whether I solve for W or L. Neither one is easier than the other. So here I'll solve for W. So 2W equals 20 minus 2L. And so I divide both sides by 2. So I have that W is equal to 10 minus L. Okay, and this is where now I do the substitution. Is now I can substitute this width here by 10 minus L. But when I look at the function that I've created, so here my y value is the area, my x value is the length of the rectangle, I see that this is a quadratic function. Okay, but in order to find the maximum, I'm going to write it first in standard form, and then I can complete the square. Okay, so here we have, I'm going to put the L squared first, so I have negative L squared plus 10L. So I see here it's definitely reasonable to talk about maximums because the leading coefficient is negative, meaning that this function is a maximum. All right, so let's complete the square. So first, factor out anything in front of the L squared. So in this case here, negative 1. So here I'm left with L squared minus 10L. Remember, I have to factor it from both terms. All right, now I'm going to complete the square inside this bracket. So L squared minus, going to write this as 2 times 5L. And so this tells me that I have to add 5 squared and subtract 5 squared. Okay, so it's these first three terms that produce my perfect square, L minus 5 squared. But of course, I still have this minus 25. And now I'm going to finish off putting it into vertex form by redistributing the negative 1. So I'm left with negative L minus 5 squared plus 25. Okay, so this is the area function now written in vertex form. So let's see what they're looking for. In this case here, they're looking for the dimensions giving the maximum area. If they wanted to know the maximum area, that would be the K value here, but they're looking for the dimensions. So from here, we see that the maximum area occurs when the length is equal to 5. In this case here, 5 centimeters. All right. But since they want the dimensions, they also want the width. I can now go back and use this equation here to find the width. So 10 minus 5. So I see that the width will also be 5 centimeters. So in other words, it's a square that's going to give me the maximum area. Now we would have known this already, okay, because you would have shown last year that a square maximizes the area of a rectangle as long as all 4 sides are being used. In this case here they are, but that's not necessarily the case if all 4 sides are not being used. All right, so just to recap, number 1, determine that it's a maximum problem, so you'll have to be completing the square. So you need a function which to maximize, which in this case here was the area, which had two variables on the right-hand side. So that's why we use the perimeter to write one variable in terms of the other and then perform this substitution. Once we did that, we can just follow our steps for finding the vertex and then answer the question that was posed. Okay, that's it for this one.